great.
In a sec, after this is fully set up.
After you do this. And then I'll do introductions
But yeah,
of our guests.
You can start now.
I'll do introductions of our guests, and then I'll do an introduction to what we've been working on. So first I want to introduce Raphael, my co-conspirator here, who's been a visiting research assistant professor here at Tulane since, I guess it was since January, right? Raphael, you arrived shortly pre-COVID.
Yeah, but officially it started December,
right.
December.
Well, Raphael's roles are many in the school, but he's been working with Byron Mouton on our urban build project, which is building a small house in Central City, where they start construction in the spring semester and finish construction in the spring semester. So Raphael's been busy with that, but he's also been with us once a week, which has been great because Raphael has serious expertise in mass timber and in wood construction broadly. He has a PhD from the University of Tokyo and has been working in Japan as well as in Finland on mass timber themes. So he's been an important part of this adventure that we've been engaging in this semester. So we have some terrific guest critics this morning. Tim Love, who we've been chatting with, is, and you all saw his lecture. The fake room background behind me is where Tim was maybe 6-7 weeks ago, giving a lecture on his work in urbanism and in relationship to different models for light industrial parts of cities. Really interesting work. But Tim and I have been corresponding often and sharing our interest in housing. And so what we're working on today is at least marginally related to that. But he's a terrific critic, and we're really pleased to have him there. He's the principal at UTIL in Boston and a professor at Northeastern University. And then Shauna Meyer is with us today. She's a lecturer at the University of Miami working on a research grant from the wood innovation people in the mass timber arena, but also teaching there as well. And her final review, I guess, is tomorrow or something. So she's in the thick of this new way that we are teaching as well. We have Derek Tynan, who's an architect in Dublin. So it's a very different time, literal time, in the part of the world that he is in, but he's an award-winning practice with a lot of focus on housing. And he is also just told me that he's currently working on a modular project, housing project in Ireland. We also have Anaki Alday, who, as you know, is our fearless leader, who probably has more pressure on him these days than anyone needs, but we're very grateful for his stewardship during these times. And we also have Kentaro Tsubaki, who is our other steward of our ship. And we are also, of course, grateful to him. So I don't think I see Deborah, but hopefully she'll pop in, and then I will introduce her. I'm going to share a few slides before we get started. This morning, we're going to be looking at 4 projects. And then in the afternoon, with a different group of critics, we will be looking at 4 more. And this was a half semester project. So I thought I would, let's see.
Hey.
Every time
Hey, it says,
oh,
yeah, sorry, I had joined the afternoon meeting by mistake. They're actually different numbers or whatever, sorry.
Yeah, that's Deborah, welcome.
Yeah,
hi. That is, of course, my fault. Because,
no, it's all right.
I thought that we had to do separate numbers, but in any event.
It doesn't matter, I figured it out.
Well, sadly, I think I've created confusion for the students, for the faculty, for the entire world, but that's, it's the world we live in. Yeah. So Deborah is a professor at Pratt University and a principal at Gans & Company Architects in Brooklyn. And Deborah has a long relationship to these themes, not so much mass timber, but certainly housing and disaster relief housing and modular housing. She is also someone who has been a good friend of the School of Architecture and of the City of New Orleans, having done a lot of work in the post-Katrina environment in that setting, and has joined us in reviews a number of times. So Deborah, we're delighted to have you.
I'm delighted to be here. I'm looking forward to learning a lot.
Okay, so every time I try to do full screen, something wrong. Can people see my screen adequately?
You just went black.
Not at this moment.
You might
Oh.
have to share again.
Yeah.
If you reshare, yeah,
Try to share the screen and not the app.
There we are.
there we are. You're back.
Okay, but apparently I can't go to full screen, so,
Huh.
okay.
Oh, no.
Oh, I know. Should I bother to reshare, team?
Yes.
Okay. I do always do it wrong. I do it from the,
Yeah, Zoom is very
From the-
finicky.
all right, so stop share. Share screen. So I do it from my desktop?
Yes, from your desktop.
Are you at school?
No, it's a fake background.
Oh,
I'm pretending.
that was good. You fooled me.
Can you now see the slide image in full screen?
Yep.
Okay, great.
Good.
All right, so this studio was part of, well, an initiative that Anaki set up in the school shortly after he joined us to emphasize research studios. And so my interest in this topic came from two experiences. One was a disaster relief kit house that Tiffany Lynn and I won a competition for and constructed a prototype of using steel structural insulated panels about, I guess it was 8 years ago now. And the other was a studio I taught on a 3,000 acre pine plantation in Mississippi 2 years ago. And so as more interest has emerged in the theme of mass timber, it struck me that there's a special relationship between timber and our region that needs to be considered more aggressively. So this is also related to the introduction of the first mass timber CLT plant using southern pine in the Gulf South, which just opened about, I think, 6 or 8 months ago, maybe a year ago, in Dothan, Alabama. A second one is coming online in Eastern Texas shortly, and a third one is scheduled to open in 2021 in Arkansas. And so these mass timber facilities had typically been located in Canada, certainly in Europe, and also in Oregon and the Pacific Southwest using Douglas fir. But southern pine has a very special role in the timber cultivation. And our region, this of course is a historic map. Most of what is shown in 1903 was later clear cut. But since in the 20th century, these woods have grown back aggressively, mostly under plantation, using various silviculture methods, but it is a growing resource rather than a diminishing resource, and a resource which is poised to be effective in the mass timber arena. So the students, I wanted to give you kind of the arc of the semester. The students initiated some research on both forestry, southern pine timber, and some economic themes, as well as some prototypes associated with timber, with mass timber, so that we could understand more about it. This is these are 4 images collaged together from their initial research, looking at certainly carbon sequestration was a key theme. And so the idea, of course, is that the Gulf South is threatened by climate change, that it is reliant on extraction industries, and that the carbon equation needs to change, and that there might be ways that these things might operate in tandem. We also looked at some economic issues, and I think this is particularly relevant now because in the post-COVID world, one of the things that we've discovered is that the the economics of forestry in this region, but probably broadly, is highly dependent on economic forces. During the recession of 2008 to whenever, stumpage prices for at sawmills went down, of course, because less building was occurring. And given the long cycle of growth for these forests, it is the lack of stability in this industry is a serious concern, which is one of the reasons why CLT could be supported by the government, a government which supports through subsidies all forms of agriculture. So pine plantation forestry could be supported as well in ways that could stabilize the market, so that it could be literally certifiable, sustainable, which is a key issue, particularly given the vast majority of ownership being in private hands in this region. So we also looked at prototypes. There have been, of course, a number of these recently, both installations and some small scale constructions, as well as, of course, larger scale constructions. Susan Jones, who's the author of the CLT House in Seattle, will be joining us this afternoon. We also looked at mass plywood a bit, and looked at some other. The Maison Domino project, by the way, is not mass timber, we discovered, but it is certainly timber.
Yeah.
But how could we resist it?
Yeah.
So the first exercise that we did was to, and this was, I think, for all of us, a kind of learning experience about how this material works relative to the materials and structural systems that we understand, both in terms of concrete and wood and steel. And so we took some interesting contemporary and maybe a few not so contemporary houses and went through a process where people first documented, tried to understand the structure as it exists, then translated it as directly as possible into mass timber. And then in a final phase, we're given the license to transform it relative to criteria that they identified, either optimization criteria or criteria that were perhaps more fluid than that. So these are example of two of them: a house by Campo Beza, and then a translation of it. The students did try to optimize the cut profiles of the planks, etc. And then this is a house in Japan by Su Fujimoto. And in this instance, it ends up having a glass skin as opposed to a concrete skin. And the dimensions, of course, change because students were paying close attention to the dimensional constraints associated with this material. We brought in a couple of guest lecturers who were extremely helpful. Tom Chung, who was the project architect on the University of Massachusetts School of Design building, that was one of the first institutional buildings in our country using this material. And Judith Shine, who is director of design, teaches at Oregon and is director of design at Tallwood Institute. So they were very terrific guests. So the students were then tasked with this idea of developing a prototype for a disaster relief structure, but it was very much tied to an idea that contrasts with what FEMA has done historically, which tries to develop an attitude towards use and reuse, and relative to the theme of time. Because of course, we're aware that historically that's been a tradition in New Orleans. A significant, of course, New Orleans is a wood city, but our interests extend beyond New Orleans. But of course, we're in New Orleans, and therefore we had that often in the back of our minds. But New Orleans is a wood city, much of that wood having been taken from those pine plantations that historic pine stands, longleaf pine, that had been in the region. But also a number of our houses were built from the wood from flatboats coming down the Ohio River, carrying goods that were then, these were built by farmers out of 2x12 oak taken from the Ohio Valley. And then they were dismantled, sold for lumber, and many of the shotgun houses in the city of New Orleans are constructed from this material that started off in a different a different way, and which was, you know, an early example, sadly uninsulated and not maybe very sustainable in that way, of solid wood construction in these barge board houses made of 2x12s arranged vertically. Of course, the FEMA approach towards disaster housing is something that we're all aware of. This is an image of the New Orleans lakefront in a year after Katrina. And of course, the above image is what ended up happening to most of these trailers after they were used for a year or two. So the idea of this, of course, was that we explored how timber could be used in modular construction. We looked at volumetric units, we looked at flat pack systems, and then gave the students some precedents which they analyzed, and then asked them to make a proposal relative to a scenario that they could design and that would be deployable rather quickly, and then eventually find a second use. And so we asked students to be as quantifiable as possible in this equation. We did go through some cost estimating spreadsheets, but I suspect you won't see much of that. You will see some carbon calculations, but this idea of building disaster relief structures out of wood probably does not make economic sense unless there's government support. Although the price of the CLT is coming down with the addition of these new factories, and it's certainly a material that's well suited towards factory production in a serial kind of way. So the students, most of the students have volumetric modules. There are some that operate somewhat differently, and you'll see that. But we did go through these calculations, and of course, depending on the scale of the unit, they might have 22 cubic meters of wood and certain carbon sequestration associated with that. A smaller unit will, of course, have less. And then in the end, of course, when you think about CLT, it upends the equation that Fuller proposed in the 20th century, which was that lightness was better, that materials like aluminum and steel were going to create a lighter house, and therefore it would have maximum advantage relative to themes of energy. So this thing has, in a sense, this proposal is inverting that equation and proposing structures that emphasize mass, sequestration of carbon, and the many aspects of timber, both psychological aspects as well as technical aspects, as an advantage worth considering. So I will stop my screen share and hand this over to Anna and James, who I believe are getting us started this morning. I'm going to set my I'm going to set a timer, so I'll let you know if we go. I'll let you know if your presentation goes on too long, but I doubt that that will be the problem.
Well, Judy, did you were you able to optimize for the video in your share?
Are you asking me, Nick?
I'm asking you.
What am I supposed to do, Nick?
No, you're good, Judith.
I have a question, Judy. Can I ask
Yeah, sure.
before we? Quick question, kind of overall question. So carbon just because I don't know regarding carbon sequestration.
Right.
Can't quite pronounce that
Right.
correctly. What happens after the building is demolished, and if it gets burned or it gets back into, it would release those carbons again?
That's right.
What is the kind of an overall framework for
Yeah.
this studio understanding that part?
So can I answer that maybe?
I was just going to ask you to
Right.
answer it, Raphael.
Great.
Right, yeah.
So yeah, the name says it, sequestration is just a temporary benefit. So
Yeah.
whether after the
Yeah.
lifespan, the materials they burn or they rotten, it will goes back to the atmosphere. So
Yeah.
as long as you don't have a really tight system working together with the forest resources, then it's just a temporary benefit. And then right now, the point that I want to reiterate, or maybe to emphasize, that was during Judith's presentation, is that I think all of us, we are sort of well aware that if we use material from sustainably grown forests, then of course we can provide renewable timber materials, and then it will help us to reduce the impacts of the construction. But one of the critical points of this exercise, also thinking about the temporary benefit of carbon sequestration, was to go further than that, to, let's say, to show that we can do better. We don't have to rely on carbon sequestration. And particularly in this case, that we are designing a short lifespan project, such as a disaster relief unit, the responsibility of the architect, it has to be extended. It's not just about making a nice building, but it's also about understanding the end of life management of the construction and its parts. So in other words, besides like having a nice designed proposal, I think in this exercise, we wanted to sort of to start the discussion, or to start the understanding of trying to see what is a life cycle approach to design. Let's say, to consider how these building materials, renewable or not, they can be disassembled and recirculated into the production process. And that's the critical improvement that will take the idea of being neutral, that is the idea of carbon sequestration, it's just neutral. And we take this idea of being neutral and we take one step further and we actually make it negative. So I think besides carbon sequestration, one of the most critical aspects of this exercise was the recirculation of these buildings or these materials again into the production circle to extend the lifespan of the buildings and the construction materials.
Right. So it is, time means everything in this equation, and reuse is certainly a part of that. So James and I think you're, let's see, are you sharing your screen still?
All right. Hi, everyone. I'm James. Annie's here too, presenting. Thanks for being here today.
Annie, you're muted.
Hi, sorry. I'm sharing my screen, so I can't see anything but my screen right now.
I think it'd be better, click view options on the top, and then you can check show video.
Under more.
Yeah, show video panel.
Oh, I see. Thank you.
No problem.
All right. How's this working? We're good.
You have to hide it because it's going to cover up your presentation. Like, we're going to see us over the video.
But
Like,
we
do you
can,
want that?
we can change the grid. Oh, I see. No, we can't.
No, Annie, like the video that you're seeing is stuck on the screen. Yeah.
Got it. Yeah.
Click the tiny box so that,
Yeah.
can you make it just one?
Yeah.
There we go.
This is fine. Okay, great.
Okay. It wouldn't be a Zoom presentation if it didn't take 5 minutes to troubleshoot.
All right.
I think that was a good conversation on the use of time to get us started. Annie, if you want to go to the next slide.
Yes.
So Judith just showed this image at the end of her presentation, but I think the thing that stood out to us most in terms of proposing a better alternative for CLT as a long-term disaster relief solution is that you really have to think about the long term. These trailers were deployed, they were meant to be deployed for 18 to 36 months. And in the case of Katrina, they were here for over 45, just sort of sitting here, slowly being sold off or disposed of as waste. If you can toggle forward, Annie. The explanation FEMA has with this basically is that the units just aren't worth keeping because they're so poorly, sort of cheaply made that they are just meant to be used for a few months. And then if people want to buy them for pennies on the dollar, they do that, or they just dispose of them. So our approach here was sort of to take the first part of their model. Sorry, I'm trying to figure out how I can annotate with an arrow. Here we go. So to take the first part of their model, which is to deploy all these units sort of in one open field for both the economy of shipping things down fast. You kind of want to be able to deploy them all in the same space rather than bring individual units to people's houses. So we kept that from the FEMA model, but where we changed things in the FEMA model, after a couple of years, they're all sort of being disposed of or thrown away. And what we proposed instead was that you could actually take these units once they're done providing immediate housing relief and move them and aggregate them to create denser long-term housing units, because, and you can still see this in New Orleans this day as a effect of Katrina, is that the housing market here has never really recovered because so much housing was lost in a short period of time. So our project really, I think, takes two phases. The first being a way of providing immediate relief to as many people as possible. The second being a way to create a long-term sustainable housing supply in the city.
So here we're showing how the CLT is produced in a plant in Dothan, Alabama, right here. And then from there, we imagine these units being deployed to many places in the Gulf South for immediate disaster relief. But before then, we started researching a little bit where these modules would be actually built. And there are many plants around the South, but we just decided that there's a plant in Lake Charles as well as Atlanta. And then from there, they would be deployed to many cities. These are just a few here. And at the bottom, we're showing how these cities, how their urban grids are, they're all varying. And these units would both be deployed in the first phase in these cities and then fit into this urban fabric of each different city. So these units, there's a single unit and a double unit, which we'll get into more later, but they're both deployed by truck. These units were designed so they could fit on a truck bed and take up basically the whole space of the truck bed. So the single unit would take up one, and then the double unit is basically two single units put together. So that would be 2 trucks per double unit.
I think it's also worth noting, just because we're the first presenters, there's not much to compare it to, but I believe that the units we ended up developing are the largest, if not one of the largest in the class.
Yeah.
I think because we intended for these to be used for long-term habitation, that we, I think, had a higher standard for amount of space.
Yeah.
So the idea that you can see here, this is for the phase 1 initial deployment, where you're deploying a lot of individual units on a low scale, sort of as quickly as possible. And we explored a few different options for this. One is sort of emulating a fairly typical city block. The second would be if you were to divide this into multiple blocks, and I think this one most closely resembles the FEMA strategy. And then the third one is if you were to keep dividing these blocks down sort of as small as possible and create a really tightly knit urban grid in this first phase of deployment.
And these sites would be places like fields next to schools, parking lots, basically any sort of full block on a city. So this is a video. This shows the units deployed all together. This would be immediately post disaster relief. Obviously the units are all grouped together pretty closely, and we can fit a lot of units on one block as shown in those site plans. So although these units are not New Orleans specific, we did want to just understand the scale of these units. As James said, they are much larger than some of the other presentations that we were about to see. But in comparison to a typical New Orleans shotgun house, they're pretty similar other than the length, obviously. New Orleans shotgun houses vary widely on their lengths, but this is a pretty average example of what that looks like. But the double and the single in terms of width on a site are pretty much the same as well as height. So they are a lot bigger. So this is showing the CLT panels and the basic construction of the double unit that we have. So you can see that right here is our single unit, and then the double unit is then added on. And this unit is interesting because we ended up using an I-beam on the floor and then also on the ceiling panel. So that just allows for a lot more rigidity, and because this unit is much larger, we are not able to have a full panel for the ceiling or the floor. So our main walls in the unit are CLT, but you can see the white walls here are stud walls, and those are making up the bathrooms and some of the basic closet walls in the double unit, which I'll show in the, we'll go to the plans in a second. These are our basic materials, obviously not every single material, but when we were doing this material study earlier on, we thought it was interesting to add that in now and just compare how the square footage has changed from single to double. And from this, we did a cost analysis as well. So oh, sorry, go ahead, James.
Well, I was just going to say that these are, I guess, cut files for the CLT blanks. So the design is sort of limited by what the plant can manufacture, which is basically 10 to 12 feet in one dimension and then 40 feet in the other. It's sort of what I think the studio decided on as typical. So we tried to work with this dimension to minimize as much waste as possible. The other thing I think that we learned and that you'll see in a lot of coming projects is that the pieces of CLT that you have to cut out of the panels, there's not really a great use for them. So it's sort of a wasteful deployment of CLT if you had, say, a lot of punch windows in a blank or something, because you end up with a lot of unusable wood that's already been harvested. So the way we dealt with this was to use the natural structural integrity of the CLT to its advantage and cut most of our windows as floor to ceiling slits, just to sort of eliminate this problem.
And here's just the double unit as well. You can see how the two have the same idea of those apertures, other than this interior wall here. So for the single and double unit, as I mentioned before, you can see the single unit here on the right side of the double unit. And then we added on an even larger piece to the double unit to create this porch here, which you'll see a little bit later how that changes with aggregation. So the double unit, we're able to get 3 bedrooms in, but this bedroom here, this wall can be removable. It's not CLT. So you can, in the case of a longer term, depending on the families that are living here, this can become an extension of the living dining area. And then this is a detail of the plan. So this wall here you can see is a polycarbonate wall. So it's a slightly translucent in order to easily take that down. And it does not go all the way up to the ceiling. So this bedroom here can easily be changed into really anything that suits the owner's need. So
And then we have just a few sectional perspectives meant to show sort of the relationship between the construction of the building, which you can see in the section cut, and then the interior space as well.
And then we have a few more section perspectives. These are a little more rendered. You can see the CLT texture, which is one of the biggest advantages of having this material. The interior, you don't need an interior finish to have a really beautiful space.
And then I think we're going to wrap up by talking a little bit more about what these look like when they're aggregated. So the idea really here being that you can combine these in multiple ways. For the sake of clarity, I think we mostly showed it as if you put a single unit on top of two double units, which I think is a fairly typical scale that could be integrated into a lot of the cities we talked about. But Annie, if you can toggle forward.
Mm-hmm.
The materiality of these was something that we dealt with for a while, and what we ended up sort of proposing is to keep them almost pretty raw in the initial deployment. So this top left study, that's Henry Blueskin, or really any long-term water barrier, and that would be sort of for the initial deployment, they would be almost like these naked units. And then when they're aggregated, you really have an opportunity to put any finished material on. So we looked a lot at hardy board. I think it's contextual here, but you could do, you know, shingles or aluminum panels or whatever is most fitting to the context.
Mm-hmm. Yeah, we wanted the aggregation cladding to be as easily applied as possible without having to take off cladding from the first phase. So as James said, that turned out as basically having the cladding for the first phase to be underneath the cladding for the second phase. And here's another one of these more detailed section perspectives where you can see this detail here where they connect, basically just sitting on top of the parapet of the unit underneath.
And this is a little oblique, just showing the relationship between the interior section and then what this thing would sort of look like when aggregated.
And then this is our final image showing how these aggregated units are stacked and then clad in many different ways and what that could look like in a typical New Orleans environment.
Great. A rather grand New Orleans environment.
Yes, yeah, maybe not typical, but.
The whole city's exactly like that. Okay.
Yeah.
So
should I leave it on this slide, or would you like me to go somewhere specific to?
well, let's why don't you leave it on that image unless one of our guests asks you to retrieve something different.
Yeah.
Can I just have a couple of questions. This is Tim. So what's given the lateral and vertical loads of CLT, what's the minimum foundation support layout? Could you have a series of sonotube poured columns coming out of the ground spaced at some distance? I'm interested in what the minimum foundation solution would be, because you tend to kind of quickly wrap it in poche. One proposal was a series of walls, CMU walls that were parallel to the length of the modules. The other is this idea of point foundations. I'm just curious what the structure allows you to how you could solve that. Because I'm imagining I'm trying to imagine what the minimal foundation solution would be.
Mhm. So for the first phase, we're imagining a CMU wall. And then for this aggregated phase, we imagine screw piles for this. So in New Orleans, obviously, you're going to need a lot more foundation support than in other cities. But yes, for the aggregation, it would be a much more permanent screw pile condition.
And then
But I think that
the foundation is just wrapped to
Yes,
enclose the actual structural solution.
right.
my understanding is that you, with a 3-ply, it depends on how many plies you have. But if you had a column grid, the point supports might vary, but they tend to be denser than other systems. So like a 10-foot grid of point supports, I think would work fine. Raphael can, of course, correct me. Or linear supports work well as well.
I think they can be either. It's just like depends on the weight, because when you have point supports, you're of course loading it perpendicular to the grain. So after a long time, you have settling. But in the case of a temporary one, then they can be point supports and they can be rather like apart from each other. You don't have to worry so much about creep of the structure.
Can I tack on to Tim's question? Or,
sure.
Yeah. So, and I had a kind of a similar reaction when I saw it first. The reaction is conflict between having a steel beam and having a load-bearing internal wall. And I'm kind of wondering, if it was a continuous wall, that could actually act as a beam too. So I'm kind of wondering whether you really actually need the beam, both in the floor and the roof. The only part that you really needed to span was the front part of the break, or you let the beam carry the load and not have the interior wall be just a regular stud wall. Or a little bit more innovative way to think about this, and I don't know if you can do this, but if you have a long continuous wall, that could actually act as a very, very deep beam. So those are the kind of the 3 things that I saw there, not to be too technical, but potential.
Yeah, and a little silly technical follow-up is you would actually get 2 walls at the center, right?
It's right in the middle.
Not 2
Yeah.
modules. And right, so that would also help, and maybe you could then do it with a T or a flange or something on top of the wall to mend the roofs together. And you probably do you just put the membrane, the roofing membrane, right on the top of the CLT, or is there another substrate? Is there insulation? Is there, at some point, oh, I see, gotcha.
Yeah, so
Yeah,
there's
so-
insulation, rigid insulation on the
Right.
outside of the CLT, and then the weather barrier.
But to pick up on Deborah's question,
Yeah.
wouldn't you have to ship in the 2-part
They're
module? Wouldn't you have to ship them as
2 boxes.
fully structurally self-sufficient elements, so
Yeah.
that you would get a doubling of the wall in the middle?
Yeah.
Which would help.
Which would help. And then you don't have that many openings on that wall that I agree that could really function as
Right.
the structural system when they
Right.
came together.
Right.
Because I was thinking, well, maybe it would make sense then, because the double wall is going to require a thicker thing to carry the load of that might be the point piles, and the
Right.
CMU walls might be only on the perimeter where they're doing double duty as a kind of skirt for the building too. And if they are separate containers, I hardwired to think this way. I would put some kind of reveal between the two containers and have express the on the end elevations, the double end walls with, I don't know, a gasket of 8 inches between them or something, as a way to fur them out and get visual credit for the doubling up of the system. But I don't know if that makes sense structurally or not. It's just you know, I've been doing reveals way back, so I believe in objectifying components. How does that sound?
Well, it makes sense in terms of cladding it, you know, because you're going to have to clad the joint somehow.
But this is Shauna. I just had a question. You know, I think it's great how meticulous you guys have been in terms of trying to understand, you know, the tectonics of the CLT. What does it mean to fabricate the panels, and then what are your sort of shipping constraints and logistics? And I think we all are sort of focused in on this double, you know, width one, and I'm wondering if there's ever a moment where it makes sense to, you know, turn your top roof panels sideways and let them just sort of lock both together. So if you are, you know, looking at sort of the urban sort of deployment of many of these structures, that the panels could still come maybe shipped without the roofs, and then at one moment, you know, come in and put all these roofs on where needed, since there's going to be, you know, many of them together. And I just ask this because I know one thing that we're very interested in is sort of limiting the amount of trades needed to work on a project, and especially in a time of, you know, disaster deployment, where it's, you know, one of the hardest things is just to get, you know, the workers and the labor force to show up. If we're able to just remove, you know, that steel component altogether, it just eliminates that coordination between trades. So, you know, I know we're all sort of jumping in very technical right away, but I think your guys' presentation was thorough, and it allowed us to do that. So we're intrigued by it.
I agree with all these comments with the structural issues. I have also questions about the lateral stability of this, but I think it's covered. I wonder if on one hand the taking radically the unit, and then how the unit can be added in different ways, and how there's change over time. You may start with one piece and then add another piece later. If there are some possibilities in the design, I don't know if I can annotate here, but imagine that instead of having this box like this, the unit, or some units are more like this. So you are building space of connections in between somehow. Of course, then this would be here and this would be here. If you can, if the space that is happening in between, you can use it for something. If you think, well, my module has the roof with the parapets of the roof, and then when I am stacking, I'm stacking on top of that. So there's something that happens here that maybe is linked to some kind of climate condition, ventilation, or whatever.
Right.
Just trying to go from the rigorous unit to the stacking with the minimum adaptations of those. No, what can you get from there? And then the other issue that I was wondering is there's in one way, when you are in the disaster relief situation, you want to maximize the interior space. So of course, no, your rectangle is all, sorry for this terrible drawing, the rectangle is all interior, because you need as much square footage as possible. So what is the resource to have expansions to the outside and have some relief space on one hand? Or also, what are the strategies for when you are building this box and then you begin to grow and evolve these units? The way they are built allows for something that was an interior space to become a porch or something else, no? If thoughts about this would change the idea of just going with perfect closed units to units that have walls and roofs that are not exactly matching. I'm just wondering about what would be, how would it look like these units when then you think in aggregation and in evolution over time. But really interesting and thorough. And let me clean all this mess.
You'll see some variations that get at some of that.
Yeah, so the idea that they become, first of all, yeah, because thanks for pulling us back, because to go back to the beginning, the whole premise that these become permanent housing, that there's no such thing in a certain sense as temporary, I think is a beautiful idea. And so we should say that to begin with, since we all just like jumped right in. But I love this notion of the gap, the spatial gap, the courtyard, the thing that's flexible between, because it is with CLT, it is a very solid, gapless, kind of airless kind of construction. And I think, especially in terms of the infrastructure, because we don't really understand the infrastructural systems and whether they're different, whether temporary and when they're permanent. And there's this idea of the gap at the scale of the courtyard is wonderful in that regard, but also the gap at the level of the chase. And I thought you were going somewhere when you said that you had stud wall construction within the CLT, because it's really hard to run services in CLT, right? You have to route out the wall. Where do you put your electrical conduit? You know, how do you get your plumbing through? And so the idea that you would create a gap by having a kind of enclosure within an enclosure, right? That the bathroom was somehow separate from the structural shell. And, you know, it's not as spatially poetic as a gap that becomes a courtyard or somewhere to live in, but it's an equally important notion of gap and air within these houses. And I think you could push that a lot further, you know, because how does that bathroom or that kitchen or that air shaft chimney effect nest within this thing that is so tight and so solid and resists penetration the way CLT does? It could be really wonderful.
Sorry, Derek speaking here.
Yeah.
Can I raise an issue just about the width, because I noticed that you're doing everything on a 10-foot module, which is 305, just over 3 meters essentially. And that presumably is the base dimension of a container, which has an ordinary load as distinct from a special load, yeah? We're looking at some items at the moment, and we're using a 4.2, 4.3 module, which is essentially 14 feet. But that's based upon a wide load presumption. So you can still put that on a truck, but it's a wide load, and so therefore that affects the I'm just wondering, was there any discussion of that in terms of deciding? I mean, I like the idea of the 10-foot because that's what it is, and then, you know, you can zoom up and down the highways with it and there's no issue, as distinct from going to the wider module, and then you have a logistics transport issue in order to move a large module.
So
Yeah,
the 10-foot was, sorry, based off of shipping, also based off of the CLT panels that are produced. The largest CLT panel that can be produced at Dothan is a 10-foot by a 40-foot. So that's really how we got the sides of our module, those walls. So those two together created that 10-foot dimension.
Okay, but the 10-foot is height, rather than the width.
Both.
I mean, yeah, okay,
Both,
but
yeah.
your heights are 10 feet, but your widths in the opposite direction needn't necessarily be that. Okay, that's fine. I agree totally about the issue of the I-beam because of the question of trades as has been suggested, and also it feels rather like, you know, when you're working with not a very good engineer, right, and you get to a certain kind of point when you say, surely we can do that in the CLT, and he says, no, you have to have this I-beam, and you think, no, you're just not a good engineer, and there's that feeling about it that there has to be another solution to that. You know, there has to be a way around needing another trade and somebody having to lift it up and a different kind of crane and all of that issue that comes with it, you know. So, and then what does it bear on? Because it feels like it's, you know, usually when one is using an I-beam or something of that sort, it's bearing onto the next thing you get a concrete or you get a steel frame, and then you've got a goalpost, and then it's moving halfway towards being steel, you know. So I think there has to be, within the technology itself, there has to be a solution of that, you know, and maybe the recognition of the double wall is the way to do that. And thank you.
Yeah, I think the comments about the I-beam are right. It wasn't there originally. We had sort of a double wall situation in that center seam, and then I think as we considered how these things would stack on top of each other, we started to get nervous about just relying on the double wall, which is how the I-beam got introduced. But I'll be the first to say that Annie and I are not engineers, so it's good to hear that the I-beam.
Bad engineers.
Just don't tell us who told you to put in the I-beam.
Would you guys go back to your last slide for 1 second, where you sort of showed it into the contextual New Orleans?
We're going to go on soon, but Shauna, finish this comment and then we'll probably need to move on.
Great. I just wanted to say, I think one thing that, you know, you did take advantage of, I don't know exactly what your ceiling heights are here, but, you know, they look to be more, you know, like maybe 10 feet high or taller. And that's one advantage when you are, you know, designing these and using these panels, is that we can use those taller ceilings. I noticed you guys place windows, you know, up at the ceiling. Perhaps they're operable. Let's assume that they are. So it seems like you guys are trying to understand how to passively, you know, inhabit these spaces and really deploy some of the, you know, material and economic efficiencies within the panel, because it's no more expensive to make, you know, an 8-foot box than a 10-foot box. And so, and that also just, I like seeing it, you know, in this context, which we all laughed about, but it allows it also this to be more contextual to those high ceilings that exist for a reason, you know, in your climate, in your context. So I do applaud you for that, thinking through it that way.
Great. Well, thank you, Annie and James, for getting us started and for your engaging animations, which I think maybe because we were operating with these little screens, we all got in, and no models and things, we all got into the animation.
That's great.
So I believe we have next Jacob.
Yeah. Let me.
Jacob, just make sure to click that optimize button.
Yeah, when I share, 1 sec. Just making sure. Oh, sorry. 1 sec. Clicked the wrong.
Are you sitting in your own design?
Yeah.
That's good.
You'll see it more later. All right, so sharing screen 1. Oh, and then I think I didn't click optimize though. Let me stop share real quick and redo that. All right, so can you see it now?
Yes.
All right, so this is Catastrophiop, a redeployable CLT kit house for interim disaster relief. My name is Jacob Silberman. And so the main idea I was kind of looking at was to like look at IKEA and how they can kind of send these houses, or like kind of developing a disaster relief solution that could be deployed on this scale very rapidly. And so the idea is, as opposed to the last one where that was modular units, we are looking at a shipping container where it's going to be a prefabricated panel assembly. So that's kind of what I was going for here when I'm comparing it to this IKEA idea, is that it would be able to be flat packed as a kit house and shipped and then deployed, and then later disassembled and possibly redeployed at another disaster. So then when I was starting this research, I started looking at just disaster relief, and the core of disaster response and recovery is the human need and the ability to meet that need in times of distress, when resources and capabilities may be limited and individuals and communities are struggling to cope with the damage and destruction of a disaster. So this is expressly true when it comes to housing assistance, whether an individual or household is seeking immediate shelter from an approaching storm or other threat, or struggling to cope with the damage to their home and personal belongings, or deciding how to repair or replace their home. So then I was kind of just like looking at the reality of like all these disasters. You can see some pictures here from Katrina. Then there was also the wildfires in California. So like the reality is that like disasters and these kind of large scale catastrophic events are more and more coming. So if we don't kind of have a better solution that can kind of rapidly respond to this, we don't want to have more of like, we looked at those FEMA trailers that kind of were a failure in 2005. So to start my research, I started by looking at the National Disaster Housing Strategy by FEMA, and they came up with this idea to develop this plan after the Hurricane Katrina, because they realized that their current plan was inadequate as a federal kind of scale. So the main kind of goals from this are, the national goals they outline are to support individuals, households, and communities in returning to self-sufficiency as quickly as possible, affirm and fulfill fundamental disaster housing responsibilities and roles, increase our collective understanding and ability to meet the needs of disaster victims and affected communities, build capabilities to provide a broad range of flexible housing options, including sheltering, interim housing, and permanent housing, build and integrate disaster housing and assistance with related community support services and long-term recovery efforts, improve disaster housing planning to better recover from disasters, including catastrophic events. So then the scenario I kind of was looking at for this CLT proposal was interim housing after a catastrophic event. And so FEMA defines interim housing as the period from the day after the disaster to approximately 18 months after a disaster. And so one of the things they kind of really emphasized a lot as well is this idea for a rapid response to a disaster. So that's kind of why I was looking at more of doing these prefabricated panels that could be shipped, because I was worried that, like, as they were just talking about with the oversized loads, that like after, when your house is looking like this, you don't want to have to wait for a million oversized modular units to come. Like, that's going to take a lot longer, whereas you could kind of rapidly ship a shipping container that fits into more modes of the transportation network. And so then the key principles related to specifically to interim housing is setting clear expectations among all those involved, extending well beyond simply providing a structure. It must be safe, secure, and accessible. It's temporary, and catastrophic incidents extend stays in interim housing and present many interim housing challenges. And then this image here on the left was kind of interesting because this was from after the California fires. And so just this idea of having to live in these RVs that are like in dim parking lots, I think is not a solution that we as a country should kind of be proposing, because like these are victims of like a huge catastrophic event. And I think we should have a more empathetic response that's like more well designed. So in 2006, one program that I looked at more was this alternative housing pilot program, which was FEMA put out $400 million to develop 4 different pilots. And so this was one I looked at here. You can see, I'm not going to talk too much about it. These are the Mississippi cottages. And so this is just kind of where I first started looking at for my design. This was like one of the first precedents. And so it just, you can see this is a trailer home built to be able to be deployed after a disaster. And then Judith was talking about her project. This is from that, the sun shower design, where they used prefabricated structural steel insulated panels to create this home for disaster relief. And so this also starts bringing in an idea that I think is kind of important to my project, and I wanted to incorporate, is of like creating a sustainable design, because like at the end of the day, I don't think it's a very good idea to not realize and react to the fact that like climate change is what's causing all these disasters. So we should try to be as responsible as possible. And then another precedent I was looking at was System 3 by Oscar Leo Kaufman from Home Delivery by the MoMA. And so this is just looking at panelized assemblies and another precedent for like modular homes and CLT homes. Now we're getting into my actual design, which you can see I designed 2 units here, a 2-bedroom, 672 square foot unit, and then a 1-bedroom, 480 square foot unit. And so these floor plans came from the Mississippi like cottages that I was looking at, like this idea of entering on the side and this more traditional trailer home layout. And so you see the 1-bedroom and the 2-bedroom. The main idea here is that these would be able to be broken up into repeatable panels. So here we have 116 by 8 panel. You'll see this more in the section. Another 16 by 8 panel, then another 16 by 8 panel, and then an 18 by 8 panel, then an 8 by 8 panel, another 8 by 8 panel. And then the floor is made up of 12 by 8 panels to make up 40 feet. And then the roof is 15 by 8. And those considerations are all coming from the high cube shipping containers. So that way they'll be able to fit into there and be able to be deployed. And so here's the section. And then another main idea here is I really wanted to have this like clerestory window on the left side because it fits this materiality of the CLT where you put like a ribbon window or something on the edge of a panel in order to not have a cutout as much, as well as later on I'll show you how it has some passive ventilation benefits as well. These are the elevations, and you can see here again the clerestory ribbon windows that run along the side. All right, now let me bring these videos over. So this is an animated assembly I made of the house, and you can kind of see what I was talking about again with those different panels. And this kind of regular construction and repeated panel sizes is to kind of speed up the time of fabrication so it can be a rapid and large scale deployment. I'll play that again. All right, and then that was for the 2-bedroom. This is for the 1-bedroom.
Is the roof CLT too?
Yeah, so the roof would be CLT panels. And then I was thinking of doing like solar shingles as a partnership through Tesla to just kind of offset the energy costs and to make them like not have to be so demanding on infrastructure. I have a slide talking more about that later. But it would be CLT panels and then with these solar shingles on top there would also be like a membrane. And so then this is these going into the shipping containers. And so this is for the 1-bedroom, I believe. Let me start it again. So this would be fitting into a 40-foot high cube container, which the dimensions are, like the interior dimensions are 39 feet 5 inches by a height of 8 feet 10 inches, and then a width of 7 feet 8 inches. And so you can see just the different components. That the idea is then that these would be all bolted together. I propose using an XRAD system, but that's one area I would like to look more, do more research in, is into the actual like more engineering aspects of fitting these together and how you could like take this design and then really engineer it to being a working proposal. So yeah, so those are all those animations. Now back to the presentation. So this is what I was talking about here with the passive ventilations with these operable windows that would allow air to blow through and cool the unit. And then this also would allow a lot of abundant natural light in this small unit and then reducing the energy costs there as well. Then lastly, this is that XRAD system, which was would be created by Rothoblast. And the innovative nature of XRAD lies in its ability to invalidate the standards of winter construction. And so you can see they can kind of get deployed vertically. And you can see here, it's getting kind of small in this presentation, but it's a lot faster than other means of the hold down angle bracket. And so that was just me looking more into this whole idea of redeploying the CLT units after the 18th month period and deploying them as quickly as possible. Because you can kind of see here, all it really needs is this, like, I didn't have a picture of it because I was running out of space, but they just have like a screw gun to screw these on site, which would be really quick after a disaster, I think. And then they're
Great.
sealed with this like foam and tape. Then this
All
was
right.
the solar shingles here,
Oh,
where I
sorry.
was talking. This is the solar shingles here that I was talking about with Tesla. And I get that these are all very like kind of expensive products, but so the idea I was kind of thinking to offset these expenses is that, like, according to like the FEMA disaster strategy, they really suggest using public-private partnerships and kind of creating a plan ahead of time. So I was proposing that possibly you could work with these companies ahead of time to like do some kind of charity or tax off like incentive to then kind of not only get these products and technology into the public realm more and like letting the consumers see it and kind of see, wow, how easy it is to have these solar shingles that would offset your energy costs and like all of that, as well as Tesla is like testing them out. And I think it's very like helping disaster victims is like a worthy cause of donating some technology. So these would be applied, there'd be a membrane on top of the CLT with the solar shingles then attached, and they would be shipped in the CLTs, I mean, into the shipping containers as well with the houses. And so that's kind of where this is, that idea of storage, deployment, and then shelter as this idea of reuse. And then, so I haven't, like, in theory, these panels would be able to be unbolted and put back into the shipping container and reused again. And that kind of brings up, I know I can kind of jump back to this section real quick. One idea is that the bathroom would be a prefabricated unit, and that's why you kind of saw that in the animations. If you were noticing that cube that was in there, that's because the bathroom would be a whole modular set, like a unit that would be manufactured, and then there would be a raised flooring, so that way all of the units and utilities would be ran underneath the floor, because these modular units have, the bathrooms have about there's an edge on the bottom that's about 4 inches. So then there would be a raised flooring in the entire unit. And also I think that's important because that's going to kind of protect the flooring CLT, because you don't want that to be getting damaged if these are going to be being reused over and over again for future disasters.
Great. Thanks, Jacob.
Yep, that's it at the end. This is the carbon summary, and then this is my last image.
Terrific.
Sorry, Derek speaking here. I'm just wondering about the approach, obviously, in terms of a panelized system has significant benefits. But I'm just wondering, in terms of a disaster relief, about the necessity to deploy labor to assemble it as distinct from something which comes essentially prefabricated. In other words, if we look at the previous one, which is essentially modular, then you put in your mini piles, you develop something to deal with the foundations and structure, and you pop it on top, and essentially 90% of the way there, right? With no necessity for local trades, local organization, logistics, etc. So clearly, when you bring the panelized version, then that takes some time to deploy, and you need skilled labor in order to do that. So I'm just wondering, was there a conversation around that balance between the two? This is not an architectural question, but simply a logistical one.
Well, that's where I was kind of looking into this XRAD system, because that's what I was thinking is like the concern is there, but like also as I was like kind of looking at these other projects, they all have some element of like, they have some stud wall or some kind of local trade element still in the design, or like they had the I-beam in that last one. There's like, so they were never able to get like 100% there. And to me, this XRAD is like it's a screw gun, pretty much like a heavy duty screw gun is it looks like what they use, which is relatively low skilled after a disaster. And
But
from what I've
it's
seen,
a real consideration. I mean,
Yeah,
for all
yes.
of these, really, a very valid point.
You know what you could though do? You could ship it. I mean, the system is great. It's kind of a Glenn Murcutt approach, right? Where it's really about taking the house apart, not putting it together, right?
Mhm.
So that you could actually ship it as a module,
Mhm.
right? But then what this fabulous thing is about is the end of that cycle and the beginning of its next life, where it can be disassembled and moved and reused either as an entity or in pieces and parts. I mean, how, you know, I don't see, I could see that kind of hybrid approach.
That's interesting.
Yeah. Where
It would
you
have to be narrower though, Deborah, you know, it would have to, then you'd have to deal
what-
with the limitations.
how wide is this thing?
12 feet.
No, you can ship 12 feet. You can do 1310 on a no without closing down a road.
I'm with
So-
Deborah on that.
Yeah. So yeah, you could do it. It you know, it's a little more than an 8-foot truck. But yeah,
Mhm.
definitely do it.
So yeah, so maybe it turns into the more kind of permanent trailer home after
Yeah.
it's assembled.
Yeah, and then, but the idea that you could take it apart and that even in the factory, the assembly is so streamlined.
Well, in that initial assembly,
Would be great too. Yeah.
that it could go, you know what I mean, to
Very
like anywhere in the world in a container and then be assembled as a permanent
Right.
solution.
Yeah. So maybe it's, you know, I know some aspects of hybridity when you use these kinds of systems isn't such a bad thing, you know, whether it's a little bit of steel or whether it's kind of part modular and part panelized. I mean, I think, or shipped one way, undone another, could, yeah, kind of interesting. It's great.
Hey, Jacob, this is Shauna. Just have, you know, I appreciate, you know, the questions that you asked at the beginning of your presentation. And I think, you know, the whole premise of the studio is set up to sort of challenge, you know, how we accept what does it mean, you know, for disaster relief or just housing communities, right? And the first project did the same. And I think, you know, one of the advantages that both of you guys have touched on in using CLT is using, you know, a wood, a natural material, a sustainable material to create, you know, a healthy living environment right away versus accepting, you know, these trailers that, you know, let alone the waste, but they're, I would argue they're not, you know, healthy living environments. But I guess I would ask you to continue to challenge the notion of what does it mean, you know, especially since yours is meant to be temporary and you talked about that temporary and you do accept that, you know, sometimes they define temporary from 45 days, but it goes up to, you know, 45 months or years, whatever. But so how do you create that healthy living environment, but accepting that it's a temporary living? And maybe we can begin to peel away, you know, some of the things that you're providing in your proposal here, you know, like, is there a reduction of just, you know, materials and maybe even programmatic elements that we can, you know, live without, you know, under this temporary notion? And I'm not asking to sacrifice a quality of life, right? But if you were to think about, and I think this maybe goes back to what Iñaki said earlier about, you know, engaging the outside spaces, right? So you're sort of expanding your footprint through these outside spaces. And then there's this notion of this maybe even smaller prefabricated or panelized thing that comes and perhaps there's a permanent element that gets built around it later on, or, you know, but just maybe it's simple and we can pull away some of these strategies. I don't know. That's just, your project's very well thought through, but that's kind of making me what it's wanting to ask.
Kind of like a more bold, tiny something more bold and like a tiny living thing is what you're saying?
Yeah, I mean, I think we all, know that the tiny, like the reduced footprint
Yeah, yeah.
or a temporary nature. And so how can, I think there's also climate elements that I know you guys aren't focusing specific on in New Orleans, but you can offer sort of an expectation to the outdoors that maybe other climates can't. But yeah.
That's a good point.
Jacob, it's really interesting this approach. I have a hate-love relation with IKEA because I hate to do things on my own. So, but one of the good things of the IKEA is that basically is for dumb people like I myself. So almost every element if you are looking for a screw, any screw that you take out from the box is useful for any moment in the building, no? Or any piece of wood is absolutely. You are not. Don't go crazy looking for that exact piece for the most part. So I wonder if in your proposal, maybe if we can just see the slide in the back.
This animation again? Like, can you see, like, which one?
No, just the slide in the back without the animation.
Oh, sorry.
So I wonder if, and I'm going to try to see if I can do a better job with the iPad in drawing. Yes. So I wonder if you can have like one kind of window, no? And one kind of whatever, beyond the structural problems that we might have seen here. But in a way, there are kind of a lot of different elements that you have to be looking for them inside the container to put it, no? So I just wonder if one way of continuing the thinking in this, not only in this project, but in this philosophy of design is how much can you reduce the number of elements that can be used in very different situations, the same element, to solve the different needs that you have.
And the simplicity of the CLT panels too, because if those windows are all vertical windows that are full height, then the panels are simpler, and there's a whole economy of means overlay to this project that I think I agree with Inaki. I think that would also help sort out questions about the order of assembly, and using the ability of CLT panels to act as the columns and supports themselves would be maybe a different way to even tackle the whole issue of fenestration. It seems funny to me that you would have continuous CLT panels and then have to use a very special kind of window with internal structure to bear the load of a heavy roof to that CLT too, versus a series of CLT panels that might go all the way to the roof with a gap between, with a series of windows that were clear story windows. For me, there's both a reduction in the number of components, but also a little bit more tectonic logic about gravity transfer from the roof down to the foundation that maybe would change some decisions that you've made. Just to pick up on what Naki is saying.
Yeah. And I wanted to tack on to that. And I was just wondering, who the hell taught these guys structures? And that was me, so I can't blame myself. But the first question is, okay, these temporary housing always have kind of a light touch. So it's an elevated above the foundation. So you have to span those the foundation posts, between those foundation posts. Isn't that correct?
I was under the impression the CLT would be able to be joined.
Well, so, the
like
CLT, you're going to be spanning the CLT panel as a floor. But what really have a structural capacity here is the exterior CLT panel vertically, because deeper the section, more capacity to span. So I've been wondering, the strategy should be not the floor supporting the wall. It's the other way around, where the wall spans between, and the floors hung from those things, as opposed to the other way around. I mean, because, you know, if the floor is actually supporting the wall, look at the wall, the section of the floor itself.
Well, that's a really good point, Kentaro. We did discover that this sort of platform frame is the preferred method. And
why is that?
I think it's because of the, well, I'll let Raphael explain that, but it's either ease of assembly, but it also, I think, the other would put a lot of strain on the bolting mechanism, the steel or whatever material the bolts are. And this is more of a gravity system.
I think it's because of the two-way nature of the CLT. It's like the two-way load. But I mean, I could be misconfused.
You can do it the way you described. I think you'd spend more on the connectors.
Yeah, the conventional, just to jump in, the conventional way, especially when you are doing in a factory, is that you lay the deck, I mean the first layer of CLT, and then you use it to have your walls plumbed and aligned and everything. So, and then you don't also have the shear force in the screws or whatever you're using to connect in the balloon framing. So it's more conventional for CLT to use the platform construction. But you can do in a small, especially in a small building like that, you could do in a different way if you find it's more economic or more efficient. But then I think it has to go through a different level of development, at least further.
But it is a good point that we don't typically make windows structural. So Jacob and I had a long series of discussions about the structural fenestration.
The reason I really wanted to do it is because, like, so if I was worried that having a roof capped at 8 feet would be too small of a living space. So this idea was to be able to expand, like you see how it's tilted here in the section. By adding this roof window that would be structural, you can separately like add the window on as a separate piece. That would be its own structural unit, like that connects to the CLT. And then you get a lot more light and just space in this unit, which kind of connects. Like, I don't want people to, like, this idea of having to live in like sardine cans was my concern.
Yeah. Well, I need to be the stern timekeeper. Is there another comment or two before we move on?
Is it okay?
Yes.
I just because that was such an interesting discussion. I mean, I do think it's an argument for hybridity, that you let things do what they can do well. So if you need a little bit of a steel post to allow to frame the transom window that sits and is carried down and spread through the CLT wall, why not? I mean, I'm not sure whether the purity of a material needs to be the thing that drives a design. So, you know, if you so these little places where you're mixing steel, you know, with the CLT, right? I mean, I think just as an interesting thing to talk about, the purity of a system versus hybridity, where, you know, that has its own logic. Just.
But Deborah, the hybridity would have to be worth it for the effect, for the
right.
You know,
right.
That would have to.
That's a different. I did not.
Continuous ribbon window would have to be so freaking important that it's worth introducing steel to the project versus a more toothy.
Right, but the toothy could be steel too if you wanted the ease of assembly. I don't know. Just yes.
Just out of curiosity, what would make a ribbon window like worth it? Because to me, like, is passive like cross ventilation and like passive light, like natural light, is that not what would be a good reason?
No, but imagine a scheme where you alternated a CLT panel going all the way up and one being down and up and down, and then you staggered the CLT for the roof so that you would get intermittent windows that you could have your cake and eat it too. So I think there's, I think my observation is that a lot of your formal choices were imposed outside of letting a little bit the constraints of the system maybe result in a form that was unexpected to you. Like the continuous ribbon window, which is a nice idea in terms of washing light on the ceiling XYZ. I don't think you might have ended up something with more weirder and more unexpected and maybe more inventive if you had really had the system itself suggest strategies for you. That was a comment I made earlier, just saying it again. But
I mean, because you have the Tarani back, because like I just did a project on the Eisenman Tarani book. So you're saying something more along that where there's like not so much regular, it's like kind of unusual, like the
no, I'm saying the opposite of Taranier and Eisenman. I'm saying more like Khan, like you know. Like I couldn't be as far from Peter Eisenman right now in my comment as I possibly could be. Just to, but I appreciate that you brought him up.
Hey,
Jacob.
Maybe can I just say one final thing? Sorry, this is Shauna.
Absolutely.
I think, I get that you're letting the 8 foot, that's a panel that's running horizontal and you're maximizing that, 8 foot dimension for the size of your box. And I think like Tim was saying, you're letting sort of the packing of the box put you in a box. But even if you had another 8 foot panel that then, actually was cut into 2 foot pieces or 4 foot pieces, right? And you sort of stacked the CLT so that your ribbon window didn't have to be continuous. But I think it's those sort of questions where, or you allow yourself to turn, think about how you're cutting up that panel and it gets longer at a moment. And so it's just questioning, going through the process, packing everything in the box, but then saying, oh, I really want this passive strategy. Then you have to go back and you have to be okay with sort of the iterative cycle of design and sort of the feedback loop where you're like, okay, I need to somehow allow myself to eliminate this 8 foot constraint on this wall. How can I do that, right?
Great final comment.
I have no, sorry. Let's go.
Well, I'm sure the next one will have opportunities for comments too. So Chanel and Maddie.
All right. So,
sorry, I was muted. Okay. All right. So, my name is Chanel Reese, and my partner for this project was, well, still is.
No divorce yet.
We'll see. Yeah.
I'm sorry, she's still here. Okay. All right. So let's get started. Okay. So when taking on this project, me and Maddie, we were very concerned with the design needs for the people who were unfortunately left behind during certain disasters. So through our research, we found that people who are normally left behind during these disasters are people with either housing or financial insecurities, people with disabilities, and some people who are just like overly confident that they can sit through and survive a storm. You can go to the next slide. So living in the South and along the coast, we are most prone to hurricanes and its disastrous storm surges. So living in either of these 10 states, which is New York, Virginia, North and South Carolina, Florida, Georgia, Alabama, Mississippi, Louisiana, and Texas. These are some of the top 10 states that are normally hit by pretty serious and disastrous hurricanes. So some of the similarities that we had found between these cities was a coastal rail line that ran through all of them called the CSX freight train. So it's really extremely important that during disasters that these resources are getting to places in need quickly. And we found that a very efficient way to do this is through train. So our module is going to start in Dothan, Alabama, and it's going to travel a journey through Tallahassee, Pensacola, and New Orleans. So a typical freight train is going to travel 14 miles per hour. And going from Dothan, it has to get to the coast. So it'll start in Tallahassee. It'll ride through all the coastal states. And it'll take about roughly 11 hours, 12 minutes, and 51 seconds for our units to arrive on site.
And getting further into that breakdown, sort of analyzing how you get from the international beams, XLOM, where the CLT is fabricated and created, and then getting it to a place such as Clayton Homes, where they make prefabricated homes, mobile and modular. We kind of analyze, okay, so how will we get this from the fabrication factory of the CLT to the prefabricator? So looking at how one truck can carry up to 7 units if it were just the panels, how much that would cost per mile and how far that is within the city of Dothan. And then looking at, okay, once these are fabricated into a module, how would the transportation work then and how much would that cost? And sort of exploring these different opportunities for transportation. But even after that, getting it to the train station, and as Chanel explained, going through Dothan, Tallahassee, Pensacola to New Orleans, you see that with the one train being able to carry 200 or more shipping containers, you're able to get more units in one train ride, which may, take 12 hours versus the 5 hours of driving. But you get more through a train than through a truck. So versus one unit, you get 200.
All right, so now we're going to get into explaining what our modular is in the breakdown of this unit we created.
So the module itself kind of stemmed from this idea of stereotomic, and then adding this extruding tectonic element, which we call the pop out, and then having sort of this transitional wall as far as the design. And next we have a GIF.
And then this GIF is just showing the breakdown of like the bathroom, the living space where the kitchen is, the bedroom, and then showing how that pop out is attached to the bedroom area. And then once we get into the floor plans, Maddie will explain how those walls can either be interchanged or where the pop out can be placed.
So to sort of provide some more variety, we kind of decided that the pop out should be able to be located either as an extension of the bedroom or an extension of the living room. So this led us to develop a variety of modules such as the L, where you have the pop out as part of the bedroom, the T, where the pop out is a part of the living room. The N, which is 2 L's mirrored from each other, which is sort of for intergenerational families, maybe like, you have your parents and also a college kid who sort of want to have that shared space within the courtyard, but also need their own separate space and are able to take care of themselves. And then we also developed the H, which is kind of 2 T's combined, which could also be for intergenerational families or a family with a small child. The T also has, the H also has a larger kitchen, as you can see here, to sort of provide for a family with more than just 1 or 2 people. And as you can see, this is kind of getting into sectional and elevational exploration of the space. So you have sort of this subdivided areas of bathroom, kitchen, living, dining, and bedroom. And you can see how the tectonic is fully expressed in its stud walls using only a polycarbonate cladding to sort of express, and differentiate from the stereotomic and the tectonic.
All right, so deployment. So once our units get onto the CSX train line, then when it gets into New Orleans, it moves over to ownership by the New Orleans Public Belt. So you can go to the next slide. So once the New Orleans Public Belt has our units on their, train line, the units are then stopped at our freight train terminal, which sits in front of our site. We'll then have a crane come into the site to be able to unload each unit. It'll be assembled, and then the crane will then place each unit in our particular arrangement on this site. So we did pick the site a little bit more closer to the river because in New Orleans, the ground right there is going to be a lot higher. So if we did run into like any storm surges or anything like that, this area wouldn't flood as bad as if you were put it on like lower ground somewhere. So after these units, and I'm just gonna talk briefly over this, after the units are no longer needed for the disaster in New Orleans, they can be backloaded onto the freight train and sent to other cities in need. Or if New Orleans would like, it can also be stored in warehouses along the city for quicker access for future disasters.
And this is just showing an aggregation plan of what we would imagine a sort of mini block of these would look like within a park or anywhere where they have extra space for the units to be deployed. So parks, stadiums, public areas.
All right, now we're gonna get into some details and calculations. So the overall square footage is gonna be about 316 square foot. The construction material consists of a Thundermax cladding system. So that's made about wood, pulp, and resin. Cross-laminated timber, we have the 2x4s and the 2x8s, and then the polycarbonate for our windows.
So this is just explaining the fabrication of the unit overall, just showing the panels, the carbon calculations. So as you can see, this particular unit is equivalent to 4 cars off the road for a year, and also energy to operate 2 homes for a year. And as you can see, even here, the pop-out is still regarded as its own separate entity that kind of gets added on later as a flat pack system. And this will kind of go through the wall sections that we have and that we explored and details that we kind of researched. We have a parapet, and similar to what Kentaro was talking about earlier, the wall goes past the roof and supports the roof rather than the roof being packed on top of the wall. And you can see the connection to the foundation. So this is exploring sort of the transition wall where we do have those windows and how that jam works. Also looking at the pop-outs wall fabrication and how the polycarbonate connects to the 2x4s. And then looking at the one window that we have in the bedroom and how you connect the floor to ceiling window with a parapet was kind of difficult, but we managed to figure it out. And then we have some visualizations of what we would imagine this environment would look like. And that's our last image.
Great, thanks.
So just a first question. So the pop-out can either...
Your audio is very low, Tim.
The pop-out can either be on...
Hey, Tim?
Yes.
It's kind of hard to hear you.
Sorry. So I have a question about the
that's good.
pop-out unit. That can either be deployed on the end of the module to make the L, or in the middle to make the T, but it's the same flat pack pieces. Is that the idea?
Yes.
Oh, that's cool. Okay.
Mm-hmm.
Can you go back to the slide where you show us your panels that you laid out? Thank you. Maybe I'm very interested that you guys chose the term, stereotomic. I mean, I appreciate that you guys really approach this through an architectural lens and are trying to explore, different architectural devices and deploy them with the same material method. But I find, the idea of carving a space while you're working with a panelized system, maybe too much juxtaposed for me to understand. So maybe you guys can talk about how you landed on that term.
Yeah, so if I go back to that diagram, at first when we were discussing it, we weren't even thinking of the CLT and the 2x4s being two separate systems, but ultimately when we landed on having this pop out that kind of added itself to the CLT, it kind of occurred to us that you can do similar things with CLT by carving out windows and such, but as a panelized system, it is something that is really solid and durable and would preferably would not have any pop out, any cutouts in it versus a stud wall where, you know, you can kind of do what you want with it and make any sort of openings and windows, which is why we kind of want to express that with the tectonic pop out and sort of have the transition to show like, yes, CLT still can do all the things that you can do with a stud wall structurally, but for more flexibility, especially within like openings and, you know, removal, it would be better to use 2x4s.
You know, that I'm looking at your diagrams while you're talking about that, and it is a lot and when you explain it, it's beautiful explanation. I think I'm wondering if the fenestration, the way you've made the windows on the stereometric box, is the thing that's making your argument unclear. And that they're kind of mimicking the tectonic, right? The frame-like lattice work. They're, when really maybe they should be minimal, or, I mean, it's a little bit Tim's discussion from last time. But in this case, you would have let this notion of the solid box versus the transparent lens of the tectonic be a slightly clearer architectural dialogue. Because I think, so that the transition is the thing that's a little confusing.
Because I, just to pick up on what Deborah's saying, and it just as a kind of a thought experiment looking at this page, which kind of explains your logic, is if the stereotomic, or whatever you wanted to call it, was a drawing of just the CLT kind of box in its purity, and both the infill panel where you've got the windows that are going up and down and the porch were both stud add-ons that would change location based on whether it was an H or an L, would be fulfilling Deborah's desire for some kind of interesting hybrid system, but those would be considered more components that would fill into the CLT box, either as a flush condition like your transition zone, or as a pop out. But there would be a clear hierarchy between CLT container volume as mass with its own tectonic logic in terms of gravity loads, and then these two kinds of kind of infill pieces, one that could be flush and one that would pop out. That's a mild misreading, I think, of what you're proposing, because in your building component diagram, you're showing the transition as part of the CLT system, where that seems to me in its expression, which I kind of like, that would be a stud, like the weird plug-in stud wall.
Right. I don't, this is Shada again. I was just going to say that, yeah, I think that the language by the transition is shared too much with the tectonic. And if you sort of switch the tectonic and the transition and maybe showed us a series of CLT panels that are modified to allow openings or to, apertures or thresholds, right? Because you have that in your design. And I think then you could also say that then a different expression altogether is the tectonic. So you sort of take us through the modifications of this system. And I think that study has great value, because I think a lot of people may have a fear about the CLT as a system as just being solid and not being able to provide, the transparency.
Please go ahead, Derek.
Sure. I I think that what's interesting in terms of your project is the ability with the addition to make some kind of spatial possibility between the pieces. And I really like that kind of conversation that you had. Sorry, excuse me. But I suppose what I was thinking of was this is the first project in a certain sense where you get a sense that there is an idea in a way about what the architecture is, of what the spatial kind of feeling of it is. I was reminded, and I'm very nervous about saying this in the company of Ms. Gans, but I was kind of went over to the bookshelf to dig out a few things. And I suppose, you know, Corb's prefabricated houses of 1940, you know, or perhaps the Chilean one, Erasmus, of 1930. Somehow they're very much about prefabricated things, but yet there's a heroic or idea about the architecture of them. And I suppose that's what one's kind of hoping that you will find here someplace. And maybe it's that the aesthetic of the CLT as being closed or wall plane versus the opening, which is other, might be explored more in such a way, rather than where we get the different windows, for example, on the current illustration, where you have a door and then you have a series of uppy-downy windows and then you have a series of other windows, etc. And it seems to me that it might be more minimalist in a certain sense, or might be more direct in terms of what is wall and what is opening. That in a way it's not as it's not as not pure is not the word, but not driven to the extent of the possibility of the technology in terms of what that might mean architecturally, in terms of solid and void, or opening or closed, or whatever. And then I look at the tectonic piece and I think porch, you know, and kind of, you think, yes, there's a long piece and then there's something at the end, and that's actually a porch, and that becomes part of the same kind of possibility of what a porch is in New Orleans. So I suppose that's a kind of want to see the architecture come through out of the system in a certain sense, that there's still that there might still be that concern, or there might still be that expression which would excite one from an architectural point of view as well as from a systemic point of view. So that's all.
I think my comment is building on this. I really appreciate the care on the exterior space, on what the quality of the space in between the houses, no, as opposed as a trailer parking that the outside is completely neglected, and your perspectives show that. I wonder if this added piece that you call tectonic can solve almost all. If you really need this, I'm trying to see if it works. If you really need this window here, or if you can just make this solid and this piece would work given the light that you need. If you really need to enter through this door, or if it can be, of course, you cannot make absolutely solid this piece, but maybe you can enter, you can get the light, and you can use this added piece as the joker that will solve everything that is not pure CLT mass, no? And it's actually a very clear architectural strategy, no? Moneo, the Miro foundation of Moneo, that is this thing of the block and the star, and there's a number of other precedents at many scales of architecture that use this technique, no? But this, having this as this completely, basically industrial, close, simple, and then you have the sophisticated element that is added in this position or added in this other position or wherever, no? Wherever is needed. And then that is what brings you the light. You enter through it, you solve the interface. And it also has this amazing quality of creating the outdoor space for the house and for the neighbors in between the houses. I think it's really promising. I would just love to see like a kind of more radical exploration.
Yaki, my caveat would be that you could either put it here as shown in this illustration, or you could put it in the middle, because that would be also a kind of infill wall that you could plug in this thing in two places based on the plans that we saw, which I thought were very smart. And I think to do that, you'd have to have some CLT wall panel, probably turn the corner a little bit. And then a piece of CLT wall panel between the two plug-in things, so the container could be structurally self-sufficient, and then you could pick one plug-in location or the other, or maybe you could do both if you were feeling double tectonic, like double pop out. But I think I agree with Inaki's kind of analysis that the clear differentiation and getting as much mileage out of the stud piece as possible is a nice idea.
So I was kind of thinking about self-reflecting and self-criticizing. I understand the previous comments that I made, and I realized two things. One is Judy said it at the very beginning, that the efficiency here is not necessarily about the lightness, structural lightness, or the efficiency of the material use. It's about carbon sequestration. That's number one. So, trying to skim on certain depths of materials is not necessarily an issue. And then, so from that logic, I think perhaps the parapet maybe a wrong way to go, because if you do try to hang something that way, I haven't really looked at the detail carefully, but you're probably going to need to introduce some other metal hardware or something that embodies different types of energy and implications. So, I don't think you can do this without doing that. I don't really understand why it has to be a parapet condition. The challenge is, if you want to prioritize from design perspective the vertical wall, then how do you detail that edge with the fact that you're putting a CLT roof on top of it, bearing it on the edge? That will be an interesting design exercise to take a look at. And the other thing is, I'm really interested. I think this is kind of a brilliant take, in a sense that you're talking about the box is a stereotomic. So it's kind of a solid CLT thing that embodies, so much carbon. And I'm kind of wondering, how do you maintain that with a kind of a minimal intervention that makes this thing livable? And the third thing is, how do you gauge the efficiency? If it's not about material efficiency, but obviously material quantity has some cost implication to it. And where is the balance that we're trying to find? Those are kind of a big questions that I have looking at the projects here. And I don't know if you have any answers to that, but.
That is a big question, which we're not going to probably solve at this point. Well, we have one more project for the morning. Should we make a transition?
Judy, before you go there, I think what was not celebrated, I suppose, in this project was the question of transport modes and the use of rail, which I think is seems a very cogent kind of thing. I mean, obviously there's the issue of transport modes and double modes and changing from one to other, and once you have to unload it, then you've got a difficulty. So clearly, if you make your site right beside the railway, that works. But if your site is 10 miles away from the railway, the issue then is that you have to offload it onto a truck, and the truck has to go to the site, etc. So you've got a lot of double and triple handling which begins to take place there. But I think the idea that you could do this by train seems to me to be something kind of quite interesting, and the analysis is done, but also I think conceptually, I think it's a useful thing to do.
Right.
Yeah, I like that aspect too.
Yeah, ditto. And I also like the site plan of the group of them and its variety too, and the way that you handled the parking as part of the site plan. It was also well done.
On the logistics question, I wanted to ask that because that's something that we're thinking a lot about, and I think is actually one of the challenges, in the US in terms of making this a commodity, right? It's cheaper right now for East Coast to get their products from Europe coming across on the water. And so you guys looked into trains, which I appreciate. Did you ever think about water transportation?
No, we actually didn't. The first iteration was through the semi-truck trailers. And then when we started looking into where our site was located, we realized that the New Orleans public belt sits directly across from our site. So we started to focus more on that and try to get enough research to kind of push that point of why this mode of transportation is better.
Right. I think that's great. And I mean, we hear that, or just what we've heard from SmartLam specifically in Dothan, is that, you can truck it anywhere. Of course it can happen, but it's just so much more expensive than the cost of some of these other modes of transportations. But then when you're trying to work on a timeline, the other modes of transportations aren't as dependable or reliable.
Mm-hmm.
So I think the question of logistics is one that even as architects, it's valid for us to dig into and to think about and to try to understand how might we use, like multimodal transportation. So thank you. I appreciate that.
Great. All right. So the last scheme is Hannah and Nick.
Hi, we'd like to thank you all for coming out to our review. My name is Hannah Bannister.
My name is Nicholas Lacazzi, as you can see in the bottom of my screen here. We were looking at ways to make this a more interesting experience for us and for you as reviewers. So we ended up creating a video presentation to kind of show our work here. So really quickly, let me share this properly. And I guess if you can just give me a thumbs up if you hear audio when I play this video. Do you see the screen right now?
Yes, but it's blank.
Okay, great. I'm gonna start now.
It's a little blurry.
Oh, whoops, my bad, sorry.
Transportation. Greenhouse gas emissions are a major contributor to global warming. In the United States, transportation accounts for 30% of annual emissions. Globally, construction contributes 39% of emissions annually. Gulf South natural disasters will increase in intensity due to global warming. As these natural disasters increase in intensity, how can we prepare for emergency housing needs in the Gulf South?
Throughout our research, we have discovered a few key challenges to housing displaced people after a disaster. Social connections, which are necessary in disaster situations where everyone is dependent on one another, wither as everyone is dispersed far from their communities. Because of this, we propose that disaster relief housing become co-housing, which is a form of housing relying on building social capital. This form of housing decreases personal interior space in favor of larger shared spaces. We've also noticed three key architectural challenges with typical disaster relief housing in the Gulf South. The first being that residences are often placed near ground level, which makes them prone to flooding during tropical storms and hurricanes. In wood-framed homes, which is typical in the Gulf South, flooding often brings mold, which can be harmful to inhabitants. In addition to flooding, natural disasters often include high wind speeds, which can do considerable damage to lightweight construction methods.
In order to combat the intensification of natural disasters in the Gulf South, we should seek to reduce our use of gas-powered vehicles. There is estimated to be as many as 2 billion parking spots in the United States alone. What will they become? Parking infrastructure is ripe for changes in use. Disaster relief housing will soon be necessary in many parts of the Gulf South. We propose that parking infrastructure is the ideal typology for these new structures for several reasons, including accessibility by vehicles, cyclists, and pedestrians, ample stair cores, and built-in access to water mains and electricity. Additionally, parking garages meet all of the challenges of Gulf to South disaster relief housing. They are elevated so as not to flood. They are built from concrete, which is mold resistant, and they are built to withstand heavy loads. Parking garages have some typical spatial adjacencies that are beneficial in disaster housing. They are often close to large communities, which helps people to find shelter near their social ties. And they are often near hospitals, which can be necessary in providing medical assistance during disaster situations. There are several different types of parking decks, and each have differing parking configurations and sloping surfaces. This brief survey shows some of the parking decks located in New Orleans. For the purposes of this project, we focused on the central two-way ramp typology as it has a high flat to ramped ratio, and we began to imagine a communal space on the central ramp.
To bolster efforts to combat global warming and to offset the embodied carbon existing in concrete parking structures, and to go towards achieving net zero energy, we suggest that these housing structures be built from Southern Pine CLT. There are 2 new plants in the Gulf South that are planning to use Southern Pine. These plants are within 300 miles of some of the cities worst hit by natural disasters in recent years. This CLT disaster relief housing is modular and will be inserted into the parking garage along this timeline, which we will go through in more detail. First, kitchen and restroom units will be fabricated and shipped to parking garages. Next, these wet modules will be craned into the garages. Following a disaster, people will bring their cars, tents, and personal belongings to the parking garage and use communal wet units for the restroom and for cooking. This temporary infrastructure is supported by the concrete structure so that displaced community members will have the opportunity to stay in the parking deck in a more permanent residence. After the number of necessary housing units is determined, living units will be prefabricated. The units start their journey in a CLT factory where all walls and floor slabs would be made out of 3-ply CLT. Those CLT panels would be shipped to a modular construction factory where stud walls would be constructed, apertures placed in, and furniture installed. Due to their small size, one of these units could be fabricated very quickly. The plan of the unit shows a small scale to space, which emphasizes the goal of building community with larger communal spaces. There is not a kitchen in the units to foster relationships between residents and reduce the size of the unit. The ceiling height maxes out the allowable height for transportation on a flatbed truck. A transom window over the front door allows additional light into the space. One living unit consists of 2 C-shaped sections and uses 589 square feet of CLT. Adding a window to the bathroom does not equal waste. Panels are cut, split, and rotated to create voids for a window on 2 separate units. 2x4 stud walls are added to the CLT for interior walls and for a plumbing wall in order to lighten the load of living units and reduce overall costs. Most of the furniture, including the bed frame and shelving, is built in. The cladding on the unit is vertical aluminum panels. The windows are frosted and the middle partition is operable. On the interior, the CLT is left exposed to create a soft natural atmosphere within the unit. The living unit is designed for 1 or 2 people. The exposed CLT makes the unit smell like a pine forest. In order to accommodate families, we have thought about expanding the unit. However, in our drawings aggregations, we have focused solely on the 1 to 2 person unit. The total cost for one living unit is approximately $20,000 or $150 per square foot. Each unit is 136 square feet and each unit weighs 9,352 pounds. The units are built such that 2 can be loaded and shipped on a single flatbed truck. After fabrication, the living units are shipped to their destination. Once they arrive, they're craned to the top of the parking garage,
where they are aggregated and communal spaces are built. Towers are constructed to increase the number of stair and elevator cores, as well as increasing density. These towers could be placed in a variety of locations not connected to a parking deck as a form of disaster relief housing. Once the people displaced from the disaster either move home or up to their more permanent unit, the parking garage may be returned to its original use, with the living units on the roof. In the first floor plan on the roof, the units are aggregated in a snaking, single-loaded corridor with wide hallways that allow for front porch-like community interaction. Communal kitchen and living spaces are interspersed throughout the complex and adjoin communal outdoor courtyards. At the center of the aggregation, the central ramp is filled with soil and becomes a large outdoor communal space with plantings. A ramp is cut through the soil, providing access to the rest of the parking garage. With this route, cyclists could bike through the entire structure from their homes to the ground level. Stairs, elevators, and a long ramp allow for access to the second story of the aggregation. Voids are cut into hallway floor slabs to allow for light to enter the floor below. Units on the first floor would have access to a shared outdoor courtyard with connections to the communal living and kitchen spaces. Hallways become gathering spaces, and residents are encouraged to add furniture to use the space socially. The freestanding towers are connected to the parking deck via a bridge. They also include communal spaces on each floor. The parking garage may still be used for its original purpose on floors other than the top floor. The parking garage is accessible via vehicle and cyclist. Residents of the rooftop are able to access their units via private elevators and stairs in the towers. Elevators and stair cores in the original parking garage are also extended, and residents can use this as a mode of entry as well. Once the units are craned into place, the insulation and cladding are placed continuously on site. Planters are added to delineate outdoor space between the units. After the need for disaster relief housing is through, the complex may be used for other purposes. Because garages are often near hospitals, these spaces could be renovated for medical uses, such as outpatient care. They could be used for dormitories, since many universities have parking garages. They could also be used for a myriad of other housing needs. Greenhouse gases are causing global warming, and our reliance on automobiles is decreasing. As a result, parking infrastructure will be less necessary in the future, while disaster housing needs will be increased. These ideas combined have led us to the conclusion that parking garages and parking infrastructure is the ideal typology for disaster relief housing, and that mass timber is the ideal building mechanism. Thank you.
Wow, pretty good, huh?
Speechless.
Speechless, awesome. And the cat on the bed, like, I know it's a very small point, but it really pulled me in. I mean, I think it's the thinking about the parking garage as the site of these was a kind of stroke of inspiration that allowed for a time frame that is realistic enough in terms of people arriving with tents with their cars, and then a kind of more quasi-permanent occupation, or I guess a permanent occupation if those are reused for a dormitory for interns at a hospital. So I think thinking through the time frame and the very smart use of GIFs too, and the animations and your voiceovers to kind of tell the story in itself was very well done. So bravo.
Thank you.
Thank you.
Can you click on number 45? Can we look at that bigger, if you don't mind? Okay. 45. Or are you able to show just parts of it or not? Do you have to go back to the video?
It might take a sec to open up, but I mean,
okay.
I mean, maybe I just show it in this view. Is that okay?
Sure. Or 44 may have been a still view. I just wanted to see the section again.
So the idea is that you build a planter on most of the last run of the ramp going up, except for you leave a thinner piece for bikes to get up. Is that the idea?
Right. I think if we show it in the plan, we cut like a little pathway through the planter that's in the central ramp, and that pathway is not necessarily straight, but we made it into an angle, as you can see.
Yeah, and this definitely brings up concerns about load and considering all of that weight on that ramp. I think this is a very idealized version of what would happen. Probably more likely it would be like smaller amounts of soil and more open, like lower spaces.
Or built up with foam. We're working on 2 projects with MBVA, and a lot of that mass is built up with the foam, and then the soil is very carefully located for trees that need, or plants that need deeper root structures. So it's possible to do this with a lighter weight technologies.
And is it, sorry, fair to, as I understand, sort of the top right and the bottom left, are those the community kitchens, or could you do like, where's the public spaces then? Are they are those it, or?
So those would be these additional modules here that are the same size of the units, but those would be the dedicated kitchen and living room spaces. So in the plan, you can kind of see some of them sticking out, and then they all have access to these like interstitial courtyards.
So one sort of C shares a space that's a living room and a space that's a kitchen.
Correct.
Yes.
Everybody, it's such a nice project. I I thought Iñaki might enjoy. I once gave a studio a little similar to this, where a group of students similar to you used a parking lot, but it was on the roof of a Kia, so that everybody ate in the dining room. And I thought, and they could use the furniture. So I thought he would appreciate that, because I know he has a fondness for Kia. Anyway, it's really a beautiful project. And you could accommodate, even with your plans, more than different kinds of alternative family groups with different amounts of co-housing, because of the way you've created the kitchen module and the social module, so that you could have a whole mini courtyard that became an extended family. Because I think social networks are so important to maintain in these disaster scenarios. People feel so atomized. If they can keep those connections, it's really, really useful. But I think you have a system that could do that. You could cluster grandparents and children and grandchildren and extended families, or even neighbors, and kind of tone the amount of sharing and the amount of privacy. So I think that's great. You should, you can articulate that in your project. And then just one little technical thing that I've seen throughout the projects, everybody is cladding things on site. There's no need, you can clad it in the factory. Especially if even if it's multiple stories, and then you just have the seam in between. But if you wanted to speed it all up and not worry about making this a construction site, there's no reason not to clad it. Small detail.
It's I was surprised, because I was imagining that when you were starting the explanation, the occupation of the parking was going to be in the interior levels.
Yeah,
we were too.
So you were.
It doesn't work.
So very good. So it. Of course, I was wondering how going to organize those, because those are very deep floor plates for light and so on. But I still think that probably in your discourse, I think there are like some like long big picture issues here. No, one is that if you are arguing that the car, and it's obvious that is going down in the use, well, let's see what happens after COVID, but hopefully it will continue going down. Car sharing and all that, these structures are less needed, so you can use not only the top but also other floors, which also takes you out from the problem of roof for your units because you are covered. So which allows you to think that the small units, the cluster of several small units generate a bigger unit because the spaces in between are already covered, no? So you can imagine other typologies coming out from here, which is also interesting. You will have like maybe a kind of thickness of the facade of those lower plants transform into housing, while the inner part of the circulation can still hold cars. You have to deal with the horizontality, which because human, we like to be horizontal because we only have 2 feet, no, 2 legs. But that's something that you can technically solve. And the interesting thing also is that this project transforms the disaster into an opportunity for the city, no, to rethink the city. So you are hacking the downtown, and you are doing, because of there's a disaster, you take the opportunity of not doing business as usual anymore, but rethinking how housing goes. So I think it's actually a really like interesting big picture strategy. I don't think I can get into the details of the construction, but I wonder about how the reformulation of the brief goes from the disaster relief to the new occupation of the downtowns, redensification of the city, and eventually a rethinking of the footprint of the city.
Just to go back to Tim's question of the tents and the idea of arrival and of temporary accommodation, super temporary accommodation in terms of tents, etc. And I'm reminded of the manner in which refugee camps develop, where they start with plots which are to do with tents, and I'm thinking of particularly those in the West Bank, and which then become cities or become towns with an extraordinary kind of density of occupation, which is problematic at a later stage. What seems interesting about this is allowing people to arrive in tents, etc., and then providing something which has an extraordinary capacity to develop into something else over time. And as has been said, to kind of intensify the city and become another resource for it. And that seems to me to be a really fantastic kind of opportunity taken to actually imagine what you have there as the tents, and then that tent city becomes something else on the roof, and that in time that becomes a community all of itself. And I think that possibility is really fantastic. I wonder just one thing in terms of whether the units have to be, they're small enough to be prefabricated in their entirety, and whether it's not a question of forklift trucks, that they come off the back of a forklift truck and they just kind of zoomed into place rather than kind of dropped or something. They seem to be of that kind of shape that you could manage to put them on some form of mechanical lifter rather than having to crane them. You know, they could just be run into place. I mean, we've done it with bathrooms and things like that, which are prefabricated, which would be half that size in certain cases, you know, where they're concrete shell types. But it just seems possible to do it with a form of forklift truck or something. Is it a forklift truck? Is that the right terminology?
I think it's the right type of terminology. We were exploring that for, initially there was going to be units everywhere, inside, outside, on the roof. But the main issue was the low ceiling heights. So I don't think a forklift truck or a flatbed truck could get inside one of these with a 12-foot like thing on top of it.
Right. Okay. Right. Okay. Thank you. Yep.
You are going to need a kind of camping infrastructure here. I mean, I love your chases so that if it were eventually in a permanent building, you could use more conventional systems. But yeah, I get it's going to be like a camper, right? With tanks of this and tanks of that that have to come and go.
Yes.
Not to be more explicit.
Right. I think that's a good point though, and something that I've been sort of questioning. Like I like the idea of the urban hacking, right? But in a way, you could deploy this, you know, on the ground or anywhere. It doesn't have to be the parking garage, and it also seems more permanent than temporary in terms of how, you know, the thoughtfulness, the urban plan, the living spaces. And so I do wonder, you know, it's sort of stuck in the middle for me. And if it is about an immediacy, then I agree completely. Like starting with the tents, showing the porta potties, showing, you know, the tanks of water next to these, you know, housing or whatever, and really like make us believe that, and then show maybe a gradual transition over time to this, you know, still middle temporary, less permanent housing situation. But I mean, the reality, especially that Deborah brought up earlier about if you're putting the cladding on site, you know, it's either a construction site or it's not, right? And I think that you guys should be very clear in drawing your lines and your approach so that it is sort of this campsite and it has all these spontaneous amenities. Like when you think about Burning Man, right? Like it seems spontaneous, but it's quite organized in terms of their organization and the infrastructure that's needed. And then how does your living units that become maybe more sophisticated, you know, insert themselves into that sort of spontaneous infrastructural system?
But there's a practical dimension to this because we have been doing some studies recently about a lot of parking garages are now overbuilt because of car share and other commuting patterns. It's true in a lot of North American cities now that the top 2 floors of garages tend to be empty even at full capacity. So this in a way relates to even these photographs. You see these very little cars on the roofs of these aerial photographs. It's also true that a lot of urban medical centers are having a housing crisis for their staffs, especially nurses and interns. So, you know, there's a version of this story that might just be focused on medical centers in times of disaster, doing this kind of triple bank shot where they are the institution or the organization that organizes relief. They're the team on site when the people show up with their cars and provide the tents. And then through some partnership with the federal government, build more semi-permanent or semi-permanent structures on the roof. And then they get those structures for their as dormitories for their own staff when they're not needed anymore. There's a tighter story here that has some realism to it that I think makes this interesting to me, just based on work we've been doing. The other thing I just wanted to say is that I thought the presentation was effective because you had the kind of classic serious documentary voiceover with great authority and the images up front of disasters, but then little moments of I would say appropriate humor with you know, the cat on the bed, or there was a nice pace of us getting sucked into the kind of the seriousness and the pragmatism of this, but the joy of the proliferation, let's say, of the towers all over the city that set up a nice cadence for the presentation that was, for me, rhetorically very effective. A kind of also communicated your pleasure in working on this, that you weren't, you know, there was the right tone for me, and maybe only for me. As Deborah knows, I'm a fairly cynical person, but but I really appreciated the presentation itself and the kind of artfulness of it.
Thank you so much.
Thank you so much. Totally agree. I totally agree. Congratulations. So 2 things I have in mind. One is this idea of that everybody was referring to tent and transition. there was a film done by a group of Thai architects presented at the, I think the second Chicago Triennial exhibit. If you, I can't recall who they are at the moment, but that reminds me that it's also kind of a urban dweller occupying an empty parking lot, and how they actually reappropriate the existing infrastructure for dwelling. It was in Bangkok, I think, and it comes to mind and something interesting to think about. And the second is this quality from that. There's this they use very, very light materials that's, kind of a wire shelving, existing stuff to create a dwelling, temporary dwelling. And it was really effective. The second thing that kind of begs the question for me is, okay, so you can do this in CLT as a prefabricated unit. You can also do it in precast, or number of different ways to do this. So what is it that, the CLT brings on the table qualitatively that makes this so wonderful as opposed to other materials?
I guess I could start and maybe start answering your question. Maybe Hannah can jump in afterwards. I think initially I would say not exactly sure, but then there's things embodied into CLT that just make it a better material use than using precast concrete or steel. It's far more sustainable. It's in sequestering carbon. If there's opportunities to use it instead of these other building materials, we should, as architects, we should be using it. I think a big question for this studio and for everyone is this material right for this scale? Or is it better for 3 to 5 story buildings where it replaces concrete 1-to-1 and steel structures? Because, I mean, thinking about costs, it doesn't make sense right now, but I think the idea is that we would be establishing a system and an economy where these costs would go down. I mean, originally we had our interior walls as CLT, and we removed those to reduce cost, just because it is far more expensive to do things that are normative, that are flat walls with this material. I think that's, I mean, I don't know.
Yes, I was going to say a lot of the same things. So
I don't want to dwell on this topic, but I think it could be an appropriate moment when you guys are questioning things right now, as municipalities, locally and internationally start to think about carbon pricing and what is the value add to, healthy building materials and sustainable materials, that it could be appropriate where you add a line item there, right, for carbon pricing. And so it starts to offset, some of those financial, when we talk about costs, as architects, we may tend to be dreamers and not always, care about the financial aspect, but as a society, we start to put an actual, fiscal value to carbon and our, global health. I think that, this could be an appropriate moment to introduce that idea.
Oh, you're muted, Judy.
It's starting to sound like a sort of summary discussion for the morning, which is always good. I mean, the question of why would, obviously people have addressed it. And relative to this particular project, I suppose I always had this vision of the sort of Kantian contrast of concrete versus wood in the domestic, in this case, in a domestic realm as a net positive. But it does bring up a larger question. And I'm sitting here wondering in the COVID moment, if what's going to happen both with construction broadly, but will office buildings, hotels, places that typically have, even dormitories, typically have used wood construction, are those projects going to go forward? Are those in a sense, do we need to find ways of promoting this material and its carbon benefits in smaller scale residential context to help solve a housing crisis independent of disasters.
I mean, it's being used in Boston now, I think, partly because of its aesthetic benefits too. I mean, just before COVID hit, there were even a couple of projects in the neighborhood where I live that at least certain components of the project were using CLT. So, I think there's the double benefit, I think, that is motivating some developers to use it.
We have in Dublin, we have a significant housing crisis. And one of the things that we're doing at the moment is looking at modular, volumetric, as described, housing, which is made about 4.3. I concur with what Deborah says. You can, I think it was 13.6, was it you said, Deborah?
Yeah, it depends on the roads and where you're going, but yeah, around that.
It translates almost directly into the metric figure that I was
Yeah,
talking
right. Yeah, exactly.
I think much better about that. But generally, because of trying to get that to heights of 6 or 8 floors, it tends to be wood frame rather than timber. And fire issues are one of the significant ones in terms of multi-unit versions of it. But nonetheless, certainly up to 3 floors, and we're looking at versions of this which are duplex and 2- and 3-story housing. It seems to be entirely possible to use it once you get over the issue of what the party walls are, because the party walls inevitably end up as masonry in this part of the world, and because nobody will rely upon. It goes back to the Great Fire of London, I think. Nobody ever.
But there's so many ways of doing that. That's not a problem.
So I think that there's a tremendous possibility in terms of that, and in terms of the sustainability and the issue of carbon tax, which in Europe is a situation where the EU has decided that if you go over a certain amount, then you actually, and Ireland has a lot of cows, which is a difficulty. We have a huge herd. And they burp a lot. Because they burp a lot, we have a lot of gas, and so that's an issue in terms of it. And I think that carbon taxing is ultimately what will happen, and it is live at the moment in terms of an economy like ours, in terms of what it has to pay in fines for not staying within its carbon kind of footprint, or its carbon allowance, shall we say.
Interestingly enough, a lot of these southern pine sawmills send their these wood pellets back to Europe for biomass burning. That helps to offset these equations that you're describing.
Which is crazy, to be moving biomass across the Atlantic in order to burn it. That does not make sense.
Well, Judy, I can say that I learned quite a bit today. I think through the scale of these projects too, about the tectonic issues and some of the logistics issues that we talked about with the last project and this project too. And I think it's a project that was framed tightly enough that other interesting issues kind of popped out of the work the students did. And I think that made all of the proposals fascinating and interesting.
Yeah, I love the way that there was always a logic of transportation, assembly, deployment, redeployment. It's slightly different than cradle to cradle, and more interesting because of the way it interacts with society and also labor. I think you could write labor narratives for all these, because there are issues with everyone says, well, the robot's going to take over, and if you denature regular construction and you make it into an industrial product, how is it going to affect construction labor and employment and all that. That people start to touch on those issues. I thought it was really interesting, and I thought there's room for expansion too, and all kinds of storytelling around that. Yeah, I learned a lot, enjoying talking to all my long lost friends here too. Learning from them. I haven't been seeing a lot of them in a while, like Tim, so it's nice. I enjoyed the projects.
I really appreciate your comments. Thank you, Tim. I really appreciate it.
Yeah.
Let me just say one thing and then I'll be quiet. As a visitor on a number of occasions to New Orleans and Tulane, what's always impressed me is the manner in which the school is grounded in the locale where it is. And this, often that's about water treatment or it's about waste treatment or whatever. And this just brings that to another kind of frontier in a certain sense in terms of the possibility of the southern pines or the timber, etc. And that seems to be a useful, very useful and significant contribution in terms of that relationship of the school to the context and to the kind of culture and everything else that it comes from. So congratulations again, as always, in terms of that groundedness of the school in Louisiana and the Gulf states.
Yeah.
And just piggybacking in Derek, thank you, and Judith for the. But I think it has this grounding that Derek is mentioning, but at the same time it's a universal implication, no? In material, in the framework, in so many things. So I really appreciate the technical rigor of the studio, the technical, the framework, the rigorous framework. And in a way, it was really interesting to see how this technical framework and rigorous framework with a connection with climate change, of course, and global warming, but also like Richard Sennett would argue with the craftsmen, what are the things that begin to be unveiled from this very craft oriented investigation that begins to pose questions at many scales, no? That are related to conviviality, to the sustainability of the city, to the reframing of the city itself. So I think it's a really interesting, very specific approach with a lot of ramifications and richness. So really enjoyed. Thank you.
Thank you.
Yeah, to follow up, just I appreciate as well the discussion today and the time that we haven't worked with CLT before, are taking to learn about the new systems and the technical approaches and the attempt at innovation. And it's great, to see New Orleans, and we're in Miami. And so we are, my partner Chris and I are, trying to tackle some of these similar things. And hopefully we'll have Judith in a review in a semester when we teach a similar studio. Right now we're focusing on like the Bahamas, so after Dorian, and we didn't have, it's the integrated studio, but Chris and I gave sort of a mass, timber overlay to our students. So it's quite interesting to see all of your projects and the idea of the prefabrication and the shipping. So I appreciate the knowledge that's being built, and I hope that sort of as Southern schools, we can start to gain and share this knowledge. And we're definitely in a little bit different of a mindset down here in Miami. It's only our second year here, but no one builds with wood yet down here. So we're trying to change that. And to your question, Judith, about the scale of the projects, I think that's a super critical question. One of the biggest advocates, which many of you mentioned in your presentations, is Woodworks. for sort of bringing, you know, mass timber construction online, and they specifically don't engage in the residential scale. You know, they do in the multifamily, but not in the single family. I mean, they're still a huge resource, but it's not one of their personal initiatives. And I think that that's a bit of a shame, because I do think that there's a lot of potential for us to deploy this, you know, building method at this scale. So I guess we'll have to all be the advocate.
Well, thank you all. I kept you a little longer than I had planned, but I'm so grateful for your time, and I know the students are as well. And particularly for visitors, you know, this new framework is, as we all know, is challenging. It has many disadvantages, but it has a few advantages. I probably wouldn't have been able to get you all in the room in New Orleans, but that doesn't mean that we won't make it happen again, because this won't go on forever. So thank you for being with us today. And we really look forward to real-time connection. I mean, real place connection.
Thanks again.
Okay, thank you. Thank
Really,
you so
really
much.
enjoyed it. Thanks.
Thank you.
Yeah.
Thank you.
Nice to see you, Tim. Thank you.
So students, I'm going to say, we'll say goodbye, go get some lunch, and then we'll talk at the end of the next session.
Yeah. Thanks.
And that's starting at 2 o'clock.
2 o'clock.
Yeah.
Be on 50. If you're presenting, be on 15 minutes early.
Take care.
So just click end stream in the top left.
I can't.
Okay.
Exit full
My
screen.
recording? No, this is for me in the live live stream. Stop live stream. Is that what I want, Nick?
Yes.